Quantum digits unlock more computational power with fewer quantum particles. The Innsbruck quantum computer stores information in individual trapped calcium atoms, each of which has 8 states, of which the scientists have used up to 7 for computing. Quantum computer works with more than 0 and 1. As we all learn from early on, digital computers work with zeros and ones, also known as binary information. This approach has worked well. In fact, it has been so successful that computers now power everything from coffee machines to self-driving cars, and it is difficult to imagine a life without them. Building on this incredible success, today's quantum computers are also developed with binary information processing in mind. The building blocks of quantum computers, however, are more than just zeros and ones, explains Martin Ringbauer, an experimental physicist from Innsbruck, Austria. Restricting them to binary systems prevents these devices from living up to their true potential. A team of scientists has now succeeded in developing a quantum computer that can perform arbitrary calculations with so-called quantum digits, qubits, thereby unlocking additional computational power with fewer quantum particles. This group is led by Thomas Mons at the Department of Experimental Physics at the University of Innsbruck. Quantum systems are different. Storing information in zeros and ones is not the most efficient way of doing calculations, but it is the simplest way. Simple typically also means reliable and robust to errors, which is why binary information has become the unchallenged standard for classical computers. However, the situation is quite different in the quantum world. For example, in the Innsbruck quantum computer, information is stored in individually trapped calcium atoms. Each of these atoms naturally has 8 different states, of which only 2 are usually used to store information. Indeed, almost all existing quantum computers have access to more quantum states than they actually use for computation. A natural approach for hardware and software. The physicists from Innsbruck now designed a quantum computer that can make use of the full potential of these atoms by computing with qubits. Contrary to the classical case, using more states does not make the computer less reliable in this instance. Quantum systems naturally have more than just 2 states, and we showed that we can control them all equally well, says Thomas Mons. On the flip side, many of the tasks that need quantum computers, such as problems in physics, chemistry, or material science, are also naturally expressed in the qubit language. Rewriting them for qubits can often make them too complicated for today's quantum computers. Working with more than zeros and ones is very natural, not only for the quantum computer but also for its applications, allowing us to unlock the true potential of quantum systems, explains Martin Ringbauer.
That was it for now. For more content like this, subscribe to our channel.